working as root again on the CentOS 7 machine, and we still have the ext4 partition that we were working with previously, so /dev/sdb1. It's not currently mounted. Even if it was mounted, I could still go through and check some data, so I can use dump E2 for the extended file system FS, and then go through and take a look at /dev/sdb1. Now we get an awful lot of information regarding the metadata of our file system and the super blocks here. So of course a lot of information scrolls off the screen. I can search for the information I need, or I can just feed it through to a paging program such as less. Now when we look at the information, what we're really interested here is if we go through and look at the reserved block count, that's currently 13,000 blocks. The block size is 4K. If we look at the total number of blocks of the block count, we can see that we're around about 250,000, so 261,000. So it's actually 5% that is the default reserved space. And this reserved space is designed for system activity, which is typically the online defrag. As we're writing data, we're making sure that it's kept contiguous with its other blocks that make up that file. Now certainly when disks weren't particularly large, this was probably reasonable, but now when we're starting to deal with 2 terabyte partitions or perhaps even larger on our GPT disk, then this could be a vast amount of space that we really don't need. And the reality is there's only when we get above about 90 or 95% of free disk space do we actually need to start using these reserved blocks in any case. So we might consider creating a lesser amount. Now we can do this at the time of formatting, or we can do it later with Tune2FS. But let's just go back and look at reformatting our file system. I don't currently have data, so I'm not worried about reformatting. The only thing that I am concerned with that I'm mounting via the UUID in the FS tab file. So I can actually maintain the same unique identifier. When we go through and take a look at the muckfs, if I go through and use muckfs.ext4, then one of the options available for the ext4 file system is specifying the unique identifier. So in this way, I don't have to worry about rewriting the information in the FS tab file. I can essentially return the current UUID and use that value here as I'm doing with muckfs. So I can go through and reformat the file system, but before I reformat it, if I use then -m, and let's just have, say, 1% of disk space here. Now when we go through and take a look at our reserved blocks, and I'm going to clear the screen, and then I can go back up and run the dump E2FS. And we can now see the reserve block have gone down from 13,000 to 2,618. And again, it's much easier to see this as 1% now because it fits in tidily with the 100% figure right above it. So 2,618 the reserve count, and 261,888 being the block count. If I quit out of this, also if I go through and let's jump into dump E2FS again and page through this, we will say that a file system check might be enforced, and that file system check could take a long time for a big file system. So I can start going through looking at some of this metadata. As I page through, we can see now that the mount count is 0 and the maximum mount count is -1. So it's been disabled anyway within the ext4 file system here. When we go through, we've got the last check date, and that's really when I've just gone through and performed my file system check. But again, the check interval is disabled as a value of 0. So in this case, I can be pretty happy that rebooting the machine isn't going to enforce the file system check unless I go through and put the file system check file at the root of the file system. But in this way, checking it before you reboot, then we know that we're not going to be caught out by any surprises of an elongated file system check, providing us some little embarrassment. So let's just quit out of this. So we've seen then a couple of the tools that we can use, but we've also got then the tune to FS. Again, with this, I could go through and change the percentage of the reserved disk space. But we can also do something like this. So -L, label it with, let's say, just data. So you can see here that I've forgotten to put in the disk. So I want the label of data, but of course I've got to specify it doesn't know what I was talking about. To be honest, it wasn't watching my video. If it had been watching the video, it would have followed what I was doing and it would have understood completely that I meant to do it for dev SDB1. But yeah, now we've set up that label. But again, I will be able to see that label through the metadata. So going back into our metadata, as we go through, we can see then the file system volume name now is data. Now I could also use then that label or the volume name as part of my mounting strategy. Generally we're going to use the UUID because we're pretty certain that's going to be unique. However, the label, of course, we're setting that so it's less likely to be unique. So hopefully that's given you an idea on some of these tools. To be honest, you may well have been familiar from these from the LPIC level 1, but remember you need to know your LPIC level 1 and the LPIC level 2 stuff, and they do mark these as specific objectives for LPI level 2. So it's worth reminding yourselves and running through these exercises if you're playing through on your own systems. So let's now move back into the slides and take a little bit more look at some of the tools that we can use.